Here in the I button and in description box below you will get complete playlist of Fourier series. Welcome to video number 6, and in this video we are going to solve fifth problem on the topic, that is Fourier series. Okay, very important problem. Before we move in this video, I would request you to subscribe to my channel, and if you learn something from my videos then please hit the like button and do share the playlist of this chapter with your friends. Okay, in this way only you can support me, and I really need your support. So let us start with this problem, that is question 5 says expand f of x equals to x sin x. Okay, the function is given as x into sin x as a Fourier series in the interval 0 to 2 pi. Okay, the interval is given as 0 to 2 pi and the function f of x is given as x into sin x. So here we can say f of x equals to x into sin x, and what is b? What this is 2 pi. Okay, what is a? It is 0. Okay, interval is basically a comma b, that is 0 to 2 pi. So if you find b minus a, that is going to give you 2 pi. Fine? Yes. So since the the interval size is 2 pi, so we can say the Fourier series for the function f of x equals to x into sin x is given by, yes, x into sin x equals to a naught upon 2 plus summation n equals to 1 to infinity a n into cos nx plus summation n equals to 1 to infinity b n into sin nx. Okay, and let's suppose this is my equation number 1. What we need to find is simply find the value of a naught, a n and b n by the help of Euler's formula. Okay, yes. So first of all we need to find what is a naught. Here a naught equals to 1 upon pi integration a to b f of x dx. Okay, a is how much? 0. B is how much? 2 pi. What is f of x? That is x into sin x. Okay, so a naught equals to 1 upon pi. Okay, here we have 1 upon pi integration 0 to 2 pi x into sin x into sin x dx. Now we need to apply chain rule here. Okay, yes. So writing this 1 upon pi here, this is my first part, this is my second part. Okay, first part is as it is, integration second part, that is integration of sin x will become minus cos x. Okay, first term is positive, second term will be negative. Fine. Yes, differentiation of this part and integration of this part. Differentiation of this part will become 1 and integration of this part. Here we have negative. Okay, negative is as it is. Integration of cos x will become sin x. Okay, so minus cos x will become minus sin x. Okay, yes. Now if you differentiate this part with respect to x, that will become 0. So we have only two terms. Okay, now the limit is from 0 to 2 pi. Okay, limit is from 0 to 2 pi here. Now simply open this bracket. Yes, we have 1 upon pi. Okay, x into minus of cos x will become minus of x into cos x. Okay, here we have minus minus, that is positive sin x. Limit is from 0 to 2 pi. Now simply put the limit. 1 upon pi is as it is. Yes, simply put the upper limit minus lower limit. If you put the upper limit, this is going to be minus 2 pi into cos 2 pi. Okay, yes. If upper limit is negative, then lower limit will be positive. Simply put 0 in place of x. This is going to be 0 because this is 0. 0 into anything will become 0. So here we have 0 in the lower limit. Now coming to this. Okay, yes, sine of 2 pi. Okay, this is positive, so lower limit will become negative, that is sine of 0. And since we know that sine 2 pi, sine 0, both are 0. Okay, so we can say we are left with this only term, that is minus 2 pi into cos of 2 pi. And we know that cos of 2 pi is how much? 1. Okay, cos of 2 pi is how much? 1. So we have minus 2 pi upon pi. Okay, minus 2 pi upon pi, that is pi will get cancelled. So we are left with minus 2. And what is minus 2? Yes, a naught equals to minus 2. Okay, so we have the value of a naught, that is how much? Minus 2. After this we'll find an. Now we'll find an. What is an? 1 upon pi integration a to b f of x cos nx dx. Here a is 0, b is 2 pi, and what is f of x? That is x into sin x. Okay, so an is going to be 1 upon pi integration 0 to 2 pi x into sin x. This is f of x into cos nx dx. Okay, yes. Now here you can see we have sin x into cos nx, but n is present in this part, so we need to write this part first. Okay, that is cos nx into sin nx. Simply change the position. Okay, cos nx into sin nx. Sorry, cos nx into sin x. Now here we are going to apply this formula, that is 2 cos a sin b. Okay, for this we need to have 2 here. Okay, because here we don't have 2, so simply multiply and divide 2. Okay, yes. So writing this in bracket because we need to apply this formula here. So this is going to 1 upon pi into half Why half? Because we have multiplied 2 here. Okay, yes, integration 0 to 2 pi. We are writing this x separately. Okay, then 2 into cos nx into sin x dx in the bracket. Okay, this part is in the bracket. Now we are going to apply this formula, that is 2 cos a sin b equals to sin a plus b minus sin a minus b. Okay, 2 cos a sin b is equals to sin a plus b minus sin a minus b. We are going to apply this formula here. So this is going to 1 upon 2 pi integration of 0 to 2 pi. Okay, here we have x. Now we can apply this formula here. Okay, we are using this curly bracket. Okay, so this is going to be, what is a? What is a? That is nx. What is b? That is x. Okay, so a plus b means nx plus x. We can take common x. Okay, so this is going to be n plus 1. So the first term would be sine of n plus 1 into x minus sine of n minus 1 into x. Then close this curly bracket, then write dx. Okay, now in the next step we are going to integrate. Okay, in the next step we are going to integrate, but while integrating we will use the chain rule. Okay, this is my first term and this whole is my second term. Okay, so this is going to 1 upon 2 pi as it is. Yes, if you integrate by the help of chain rule, this is my first function as it is. The integration of second function, that is sine will become minus cos. Okay, minus cos n plus 1 into x, and the coefficient of x is what? N plus 1. So write n plus 1 in the denominator part. Okay, now again sine, integration of sine will become minus cos. Because of this negative, this will become positive. Okay, so this is going to be cos of n minus 1 into x upon coefficient of x, that is n minus 1 in the denominator part. Okay, yes, now we will differentiate this. Okay, first term positive, this is positive, then second term would be negative. Now differentiation of this part will become 1. Now integration of this. Okay, integration of this second part. Okay, so minus is as it is. Integration of cos will become sine of n plus 1 into x upon n plus 1. We have already one n plus 1, that is n plus 1 into n plus 1, that is n plus 1 whole square. Similarly here also, yes, integration of cos will become sine. So this is going to be sine of n minus 1 into x upon n minus 1. Due to this n minus 1, we have n minus 1 into n minus 1, that is n minus 1 whole square. Okay, now differentiation of this part will become 0. So no need to write the third term. This is my first term. Okay, minus second term. Third term would have been positive, then fourth term would have been negative, and so on. But third term doesn't exist because of this. Okay, if you differentiate this, you will get 0. Now put the limit, that is 0 to 2 pi. Fine. Yes, after this we need to put the limit. Okay, simply put the upper limit. Here we have 1 upon 2 pi, no need to change this. If you put x equals to, okay, 2 pi, this is going to be 2 pi. Yes, here again you can see minus cos of n plus 1 into 2 pi upon n plus 1. Okay, here we have cos of n minus 1 into 2 pi upon n minus 1. Okay, yes. Now if you put lower limit as 0, this upper limit is positive, then lower limit would be negative. Okay, here it is 0. Why 0? Yes, here we have x into something. Okay, x into something. If this x equal to 0, if you put x equal to 0, then 0 into this thing will become 0. So upper limit this, lower limit 0. Okay, now we'll come to the second term. Okay, that is if you put the upper limit. Okay, here we have negative sign. Yes, in this curly bracket we have minus sign n plus 1 into x. Okay, in place of x we need to put 2 pi. Okay, so minus of n plus 1 into 2 pi upon n plus 1 whole square. Okay, similarly if you put lower limit here, upper limit negative, so lower limit would be positive. Okay, so this is going to be sine of 0 upon n plus 1 whole square. Okay, similarly here also simply put the upper limit and lower limit. Upper limit would be sine of n minus 1 into 2 pi upon n minus 1 whole square minus sine 0. Okay, simply put 0 here, sine 0 upon n minus 1 whole square. Okay, yes. Now since we have n minus 1, okay, here you can see we have n minus 1 in the denominator part, so we cannot say that while finding an, we are finding an. Okay, yes, here you can see we are right now looking for an. So and the value of n goes from 1 to infinity. Okay, but you cannot put n equals to 1 here, because if you put n equals to 1 here, this term would become infinity. Okay, so we can say this an exists for n equals to 2 to infinity. Okay, here we are finding an for n equals to 2 to infinity. Okay, so if you put n equals to 2, 3, 4, 5 up to infinity, so this term would become, okay, this is going to be 0, This is again going to be 0. This term is again going to be 0, and this is also 0. Okay, this 4 term will become 0. So finally we are left with only 2 terms. Okay, yes. Again, if you put n equals to 2, 3, 4, 5 up to infinity, we cannot put n equals to 1, because if you put n equals to 1, then this will become infinite. Okay, this term will become infinite. Simply put n equals to 2, 3, 4, 5 up to infinity. It means this an, okay, we are finding an where n goes from 2 to infinity. It also means that we need to find a1 separately. Okay, due to this n minus 1 in the denominator part, we cannot put n equals to 1. Okay, so an is for n equals to 2 to infinity. It means we need to find a1 separately. So yes, this is going to be 1. Okay, cos of n plus 1 into 2 pi. If you put n equals to 2, 3, 4, 5, any value, okay, any natural number apart from 1, you will get this value is how much? 1. So this is going to be, yes, here we have 1 upon 2 pi into pi. Okay, we have 1 upon 2 pi into 2 pi. Okay, yes. Again here we have only 2 terms. Okay, that is minus of cos of n plus 1 into 2 pi upon n plus 1. If you put n equals to any value, okay, from 2 to infinity, you will get this value as 1 always. So this is going to be minus 1 upon n plus 1. Again here also, if you put n equals to 2 to infinity, any value, you are going to get this one, this value as 1. So this is going to 1 upon n minus 1. Okay, so this part will get cancelled. So 1 is left in the outside of this bracket. Simply take the LCM, that is n plus 1 into n minus 1 is going to give you what? N minus 1. Okay, n square minus 1. N plus 1 into n minus 1 is going to give you n square minus 1. Now simply cross multiply. Here if you multiply this, then this is, okay, this will be negative and this will become positive. Okay, here we have positive sign, so no change, that is n plus 1. Here you can see n will get cancelled, so you are left with 2 upon n square minus 1. Okay, yes, this is the value of an. I am writing here, this is the value of an when n is not equal to 0. Okay, when n is not equal to 0. Okay, sorry, n is not equals to 1, because the value of n should go from 1 to infinity. Okay, yes, if you see in the summation part, the value of n goes from 1 to infinity, but you cannot say here n equals to 1 because of this n minus 1 in the denominator part. Okay, again I am saying, if you put n equals to 1, this whole term will become infinite. Okay, so we have found an when n goes from 2 to infinity. Okay, so this value of an is not when n equals to 1. Okay, so we need to find a1 separately. Okay, so remember, an equals to 2 upon n square minus 1. Let us find a1. Yes, now we are looking to find a1. Okay, yes, if n equals to 1, then here it should be 1. Okay, that is while finding an, this was cos nx. Okay, but since we are finding a1, so it should be cos x. Okay, simply put n equals to 1, so cos nx will become cos x. Okay, yes, so a1 equals to 1 upon pi integration 0 to 2 pi x into sin x into cos x dx. Okay, yes, now simply multiply and divide 2. Okay, yes, if you divide and multiply 2, here we have 1 upon pi into 1 upon 2 integration 0 to 2 pi x into, here we have 2, that is 2 into sin x into cos x dx. Fine, yes. Now 2 sin x cos x is sin 2x. Okay, so simply multiply both, you will get 1 upon 2 pi integration 0 to 2 pi x into sin 2x dx. Now we will apply the chain rule. Okay, yes, we will integrate this part by the help of chain rule. So 1 upon 2 pi is as it is, this first function is as it is, simply integrate the second function, that is integration of sin will become minus cos. So this is going to be minus cos 2x upon coefficient of x, that is 2. Okay, yes, in the denominator part. Now again, first term positive, second term would be negative. Differentiation of first term, first part, that is 1. Now integrate this part. So minus is as it is. Integration of cos is sine. Okay, this minus is as it is. Integration of cos is sine. So sine 2x upon 2. Here already we have 2. So 2 into 2, that is 4. Okay. Now third term would be 0 because of this 1. If you differentiate this further, you will get 0. Now put the limit, that is 0 to 2 pi. Okay. Yes. Now simply open the bracket, you have 1 upon 2 pi as it is. If you open this bracket, you have minus of x into cos 2x upon 2. Okay, and here negative negative positive, so here we have sin 2x upon 4. Okay, limit is from 0 to 2 pi. Now we will put the limit. Okay, yes, so 1 upon 2 pi is as it is. If you put the upper limit, so you are going to have minus of, okay, in place of x we need to put 2 pi. Okay, so minus of, yes, so here you can see, here we have minus of 2 pi into cos of 2 into 2 pi, that is cos of 4 pi upon 2. Okay, now upper limit negative, so lower limit would be positive. Upper limit is negative, so lower limit will be positive. If you put x equal to 0 here, this is going to be 0. Okay, so upper limit, lower limit. Okay, upper limit negative, so lower limit positive. Now coming to the second term, if you put the upper limit, this is going to be cosine of 4 pi upon 4. If you put lower limit negative, upper limit positive, lower limit negative, so this is going to be sine 0 upon 4. Okay, now this is going to be 0. This is also going to be 0. So finally we are left with this into this. Okay. Yes. Cos of 4 pi is how much? 1. Okay. So this is going to be minus, okay, minus 2 pi upon 2 pi into 2. Okay. So this 2 into 2 pi will become 4 pi, and we have minus of 2 pi. This is 1. Okay. So we have minus 2 pi upon 4 pi. Pi get cancelled. This is 1 upon 2. With this negative sign, this is minus 1 upon 2. So finally we can say what is the value of a1? a1 is how much? Minus 1 upon 2. Okay. So we have a0, a1, an. Now we will see what is the value of bn. Yes. Bn equals to 1 upon pi integration a to b f of x sin nx dx. What is a? 0. What is b? 2 pi. What is f of x? X into sin x. Okay. So here we have, yes, bn equals to 1 upon pi integration 0 to 2 pi x into sin nx dx. Okay. Now here again we can see we need to use this formula, that is 2 sin a into sin b. Okay. Yes, here we have 2 sin. Okay, so we need to use this formula, that is 2 sin a sin b, which is equals to cos a minus b minus of cos a plus b. Okay, simply remember this formula. But while writing this, we need to first this part, because this contains n. Okay, but this contains does not contains n. Okay, yes, this does not contain n, this contains n, so we need to write this first. Okay, that is sin nx into sin x. Okay, yes, simply multiply 2, because in this formula we have 2. Okay, if you multiply 2, then we have to divide 2 also. Okay, so here we have 1 upon pi into 1 upon 2 integration 0 to 2 pi x into 2 into sin nx into sin x. Okay, simply write dx at the last. Now we'll apply this formula. Okay, so here a is nx and what is b? That is x. So 1 upon 2 pi as it is, integration 0 to 2 pi, x is as it is. This is going to be cos, yes, we have a as nx and x as b. Okay, that is nx minus n. Okay, nx minus x. So if you take x common, so we are left with cos of n minus 1 x. Similarly, with this negative sign, we are going to write cos of n plus 1 into x. Okay, right here dx. Now in the next step, we are going to integrate. Okay, yes. So 1 upon 2 pi as it is. Yes, here we are going to use the chain rule while integrating, because this is my first function. Okay, and this is my second function. Okay, this complete. Okay, this complete is my second function. So first part is as it is, integration of second function, that is cos will become sine. Okay, sine n minus 1 x upon coefficient of this n, that is n minus 1. Similarly here also minus of sine n plus 1 into x upon coefficient of this x, that is n plus 1. Okay, now differentiation of this part with negative sign, first term positive, second term negative, differentiation of first term, second, okay, first part, and integration of second part. Okay, so differentiation of first part will become 1, integration of this part will become, yes, integration of sign is what? Minus cos. So this is going to be minus cos into n minus 1 into x, n minus 1 into x upon n minus 1 into n minus 1, that is n minus 1 whole square. Okay, again integration of sign will become minus cos, so minus minus will become positive. Okay, here we have cos of n minus 1 into x upon n plus 1. Here again we have n plus 1, so it is n plus 1 whole square. Okay, yes. Now yes, the range is from 0 to 2 pi, so simply write 0 to 2 pi. Yes. Okay, yes. Here simply put the limits. Okay, here we have 1 upon 2 pi as it is. Yes, if you put the limit, okay, upper limit here, so this is going to be 2 pi. In place of x we need to write 2 pi only. Okay, so this is going to be 2 pi into sine of n minus 1 into 2 pi upon n minus 1. Similarly here also we have sine of n plus 1 into x, that is 2 pi upon n plus 1. Okay, yes, this is upper limit. Okay, this part is upper limit. Now upper limit positive, then lower limit would be negative. Okay, now put this lower limit 0 here, so 0 into anything will be 0, so lower limit would be 0. Okay, now coming to the second term. Okay, here we have negative sign. Yes, So simply minus of cos. Okay. If you put the upper limit, this is going to minus cos n minus 1 into 2 pi upon n minus 1 whole square. Here again we have, yes, with this positive sign, we can write cos of n plus 1 into 2 pi upon n plus 1 whole square. Now we'll put the lower limit. Okay, yes, upper limit negative, then lower limit will be positive. Okay, yes, here we have cos 0 upon n minus 1 whole square. Again, we will put the lower limit here also. Okay, in place of x, we need to put 0 only. That is, upper limit positive, then lower limit would be negative. Okay, so this is going to be cos, okay, 0. Okay, if you put x equal to 0 here, this is going to be cos 0 upon n plus 1 whole square. Okay, I hope up to this part it is very much clear to you. Okay, yes. Now you know, here we have n minus 1 in the denominator part. Okay, here we have n minus 1 in the denominator part. So we cannot put n equals to 1 here. Okay, the value of n starts from 1 to infinity. Okay, n belongs to natural number which goes from 1 to infinity. But if you put n equals to 1, then this part will become infinity, this part will become infinity, this part will also become infinity. So the value of bn, yes, we are finding what? We are finding bn. So the bn value, okay, whatever the value of bn comes, yes, here the value of n goes from 2 to infinity. Okay, 2 to infinity. Because if you put n equals to 1, this term will become negative, infinity, this term will become infinity, this term will become infinity. Okay, yes, it means we need to find b1 separately. Okay, yes, so if you put n equals to 2 to infinity, this term will become 0. Okay, yes, this term will also become 0. Fine, so we are left with only 4 terms, that is this, this and this. Okay, so simply writing one by one. So here we have 1 upon 2 pi. Yes, remember one thing, that we have this negative sign, so minus will become positive. This, if you put n equals to 2 to infinity, this is going to be, yes, 1. Similarly, this will also become 1. Cos 0 is 1, cos 0 is 1. Okay, so we have numerator as 1 in all 4 terms. So here we have negative, that is positive, 1 upon 1 minus, sorry, n minus 1 whole square. Again, minus plus minus. Okay, here we have minus plus minus, that is 1 upon 1 plus n plus 1 whole square. Okay, again negative, positive, negative. Okay, 1 upon n minus 1 whole square. Here again negative, that is positive, 1 upon n plus 1 whole square. Okay, now here you can see, yes, here you can observe one thing, that is 1 upon n minus 1 whole square, and here we have 1 minus, okay, 1 upon n minus 1 whole square, but this is positive, this is negative, cancel out. Here again positive, negative, 1 upon n plus 1 whole square, 1 upon n plus 1 whole square, both will get cancel out. Okay, so here we have bn equals to 0. Okay, yes, finally we get, that is bn equals to 0. But remember one thing, the value of n goes from 2 to infinity. Okay, yes, because at n equals to 1, this term, okay, this term will become infinite. Okay, so yes, we need to find b1 separately, because the value of bn goes becomes 0 when n equals to 2 to infinity. Okay, so this value is not when n equals to 1, so we need to find b1 separately. Okay, let us find. Now we will find what is b1. Okay, yes, if you put n equals to 1, okay, if you put n equals to 1 in this bn, yes, here you can see this is bn, and what is bn? Yes, this is, that is 1 upon pi integration 0 to 2 pi x into sine n x into sine nx dx. If you put n equals to 1, then we are finding what? b1. Okay, put n equals to 1, this is b1, and here this will become 1 upon pi into integration 0 to 2 pi x into sine x dx. Sine x into sine x will become sine square x. Okay, so this is going to be 1 upon pi integration 0 to 2 pi x into sine square x into dx. Fine. So b1 is going to 1 upon pi integration 0 to 2 pi x into sine square x dx. Now, yes, we know this formula, that is cos of 2. Okay, cos of 2x equals to 1 minus 2 sine square x. Okay, cos 2x equals to 1 minus 2 sine square x. If you find sine square x, then this would be, yes, 1 minus cos 2x upon 2. Okay, what is sine square x? That is 1 minus cos 2x upon 2. So yes, we can write b1 as 1 upon pi integration 0 to 2 pi x into 1 minus cos 2x upon 2 dx here. Okay, now we will simply apply the chain rule to solve this integration. So yes, taking this 2 here, that is 1 upon 2 pi. Yes, first function as it is, that is x, integration of second function. Okay, so yes, we have already taken this 2 here. Okay, so this is left with 1 minus cos 2x. So 1 will become, okay, x, and sine cos 2x will become sine of 2x upon 2. Okay, cos 2x with negative sign will become minus of sine 2x upon 2. Okay, this negative is as it is. Integration of cos 2x will be sine 2x upon 2. Fine. Yes, this is the first term. Second term, yes, first term positive, second term will be negative. In differentiation of first part, that is 1. Integration of second part, that is x will become x square upon 2. Yes, negative as it is. Integration of sine will become minus cos, so minus minus will become positive. Okay, yes, this is going to be cos of 2x upon 2. 2 into 2, that is 4. Now put the limit, that is from 0 to 2 pi. Okay, now we'll open this bracket. So 1 upon 2 pi is as it is. If you open this bracket, here we have x square minus x into sine 2x upon 2. Here again, if you open this bracket, this is going to be negative x square upon 2 minus cos 2x upon 4. Okay, limit is from 0 to 2 pi. Now again, yes, here we have x square, here we have minus of x square upon 2. Okay, so if you solve both, you will get x square upon 2. Okay, so 1 upon 2 pi is as it is. If you solve both, you will get x square upon 2. Rest two terms are as it is, that is minus of x sine 2x upon 2. Here we have minus cos 2x upon 4. Limit is from 0 to 2 pi. Fine. Now if you put the limits, okay, now we will put the limits. So this is going to be 1 upon pi. Okay, yes, this is going to be in place of x we need to put 2 pi, so this is going to be 4 pi square upon 2. Okay, here again, yes, if you put the lower limit, okay, lower limit, upper limit positive, lower limit would be negative. Okay, lower limit will become 0. If you put x equal to 0, this is going to be 0. Now coming to the second term, put x equals to 2 pi here, so this is going to be minus of 2 pi into sine 4 pi upon 2. Upper limit negative, then lower limit would be positive. If you put x equal to 0 here, then this will be again 0. Fine. Yes. Now coming to the third term, okay, that is minus of cos 2x upon 4. If you put the upper limit, then this will be minus of cos 4 pi upon 4. If you put the lower limit, upper limit negative, then lower limit would be positive, cos of 0 upon 4. Okay, I hope this step is very much clear to you. Okay, yes, here again you can see, yes, this will become 0. Okay, yes, again we know that is cos 0 is how much? 1. Cos 4 pi again is 1. So here we have 1 upon 4. Here we have minus 1 upon 4. So both term will get cancelled out. Okay, so finally we are left with these two. Okay, that is 1 upon 2 pi into 4 pi square upon 2. Okay, so 2 to 4. Okay, yes, you can see 1 upon 2 pi as it is. Here we have 4 pi square upon 2. So here you can see pi gets cancelled. Okay, 2 to 4 get cancelled. So finally we are left with only pi. So b1 equals to how much? Pi. Okay, b1 equals to pi. Now we'll come to the equation number 1. What is equation number 1? This is my equation number 1. X into sine x equals to a naught upon 2 plus summation n equals to 1 to infinity a n into cos nx plus summation n equals to 1 to infinity bn into sine nx. Okay, and what is the value of a naught? Yes, a naught equals to minus 2. Okay, a naught equals to minus 2. A1 equals to, yes, a n equals to 2 upon n square minus 1 when n is not equals to 1. Okay, so we have found a1 separately, that is minus 1 upon 2. Again, bn equals to 0 when n is not equal to 1, and we have found b1 separately, that is pi. Okay, so first we'll put a naught. Okay, a naught upon 2. What is a naught? That is minus 2. So minus 2 upon 2 will become minus 1. Okay, I hope this part is clear. Now while finding this, first of all we'll find a n into cos nx. Okay, yes, put n equals to 1. Okay, so this is going to be a1 into cos x. Okay, a1 into cos x. What is a1? That is minus half. So minus half into cos x. Okay, yes, it means while putting a n, okay, the value of n goes from 2. Okay, okay, so now again move ahead. Here we have put a1 into cos x. What is a1? That is minus half. So this is also achieved. Now we'll put b1. Okay, what is b1? That is pi. Okay, b1 into sine x. So b1, that is pi into sine x with this positive sign. Now we'll come to this part when n equals to 2 to infinity. Again we'll come to this part when n equals to 2 to infinity. But bn equal to 0. So we'll not take this term. Okay, simply we take this term, but n equals to 2 to infinity. So this is going to be a2 cos 2x. Okay, yes, cos 2x. And what is an? Yes, n equals to n square upon, okay, and sorry, 2 upon n square minus 1. If you put n equals to 2, okay, this is going to be 2 upon 2 square, because n equals to 2 to infinity. So it is going to be 2 upon 2 square minus 1. Okay, 2 upon 2 square minus 1 into cos 2x, because we are putting x n equals to 2. Now again, if you put x equals to 3, sorry, n equals to 3, then this is going to be 2 upon 3 square minus 1. 2 upon 3 square minus 1 into cos 3x, okay, plus dot dot dot. Don't forget to write this dot dot dot, and this is what? This is the final Fourier series of this function, that is x into sin x, okay? Yes, thank you so much.